Magandang buhay, grade 10 learners. Again, here's another journey of learning entitled Sector and Segment of a Circle. At the end of the lesson, the students are expected to illustrate seconds, tangents, segments, and sectors of a circle. Let us subdivide this objective. Letter A, define sector and segment of a circle. Letter B, find the area of the sector and segment of a circle. Let's have a review first. Given the figure on the right, find the measure of the following. Let's start with arc PN. Arc PN is intercepted by angle PLN. Angle PLN is formed on the circle, so it is an inscribed angle. Remember, the measure of an inscribed angle is always 1/2 of its intercepted arc, or the measure of the arc is 2 times the measure of the angle which intercepts it. Therefore, the measure of arc PN is equal to 2 times the measure of angle PLN. The measure of angle PLN is 68 degrees times 2, and that is equal to 136 degrees. So arc PN measures 136 degrees. Number 2, let's get the measure of arc LN. The degree measure of a circle is 360 degrees. Remember, we have already measured of arc PL, arc PN, and we need to get the measure of arc LN. To get the measure of arc LN, this is equal to 360 minus the sum of the measures of arc PL and arc PN. 360 minus quantity 92 degrees plus 136 degrees. 92 degrees plus 136 degrees is equal to 228 degrees. 360 degrees minus 228 degrees is equal to 132 degrees. Number 3, let's get the measure of angle L and P. Angle L and P is an inscribed angle. It intercepts arc LP. So that is equal to 1/2 of 92 degrees. And 1/2 of 92 is 46 degrees. Let's proceed to our lesson proper. Sector of a circle. It is a region bounded by an arc of the circle and the two radii to the endpoints of the arc. In this figure, the shaded part, which is colored green, is what we call as sector. To find the area of the sector, get the product of the ratio, measure of the arc all over 360, and the area of the circle. The area of the circle is equal to pi r square. Therefore, in symbol, we have area of the sector equals measure of the arc all over 360 times pi r square. Another definition is the segment of a circle. It is a region bounded by an arc and the segment joining its endpoints. Look at the given figure. The shaded part, which is colored orange, is what we call a segment of the circle. To find the area of a segment of a circle, subtract the area of the triangle formed from the area of the sector. To apply the concepts, let's have the following examples. Number 1. Find the area of the shaded region of each circle on the right. Given the circle on the right, there is a central angle measuring 100 degrees. The arc intercepted is also equal to 100 degrees, and the radius is 7 centimeter. By using the area of the sector formula, we have the area of the sector is equal to measure of the arc all over 360 times pi r squared. By substitution, we have area of the sector equals 100 all over 360 times pi times the measure of the radius, which is 7 centimeter square. Pi is equal to 3.14 and 7 centimeter square is equal to 49 centimeter square. The area of the sector is equal to 5 over 18 times 3.14 times 49 centimeter square. 100 over 360 is transformed into its lowest term, which is 5 over 18. By manual computation or by using calculator, 5 times 3.14 times 49 centimeter square divided by 18, that is equal to 42.74 centimeter square. Number 2, the given circle on the right shows that the shaded part is a segment of the circle. The arc of the circle measures 60 degrees and the radius is equal to 12 centimeter. To get the area of the segment of the circle, first, find the area of the sector by using the formula area of the sector equals measure of the arc all over 360 degrees times pi r squared. The area of the sector by substitution, we have 60 all over 360 times pi times 12 centimeter square. Pi is 3.14 and 12 centimeter square is equal to 144 centimeter square. So the area of the sector is equal to 1/6 times 3.14 times 144 centimeter square, and that is equal to 75.36 centimeter square. After getting the area of the sector, second, find the area of the triangle formed. The area of the isosceles triangle formed is equal to r squared divided by 2, and that is equal to 12 centimeter square divided by 2. 12 centimeter square is equal to 144 centimeter square. 144 centimeter square divided by 2 is equal to 72 centimeter square. As a final solution, to get the area of the segment of the circle, that is equal to area of the sector minus the area of the triangle formed. 75.36 centimeter square minus 72 centimeter square is equal to 3.36 centimeter square. That's all for today, grade 10 learners. Hanggang sa muli!